Hi, Graham Roberts here. This is the second tutorial in the series about databases. So the very first thing we do is identify the entities, because that's what we need to know about. And we know there are 4 types: people, locations, events and things. Not just for our model, which is retail, but any model. This is a wonderful thing. There are only these 4 entities. So it helps to identify which entities we need by knowing there are only these 4 types. The next thing we need to do is identify the relationships between them. As we saw earlier, there are relationships, and what we need to do is get specific. So we need to change these into specific entities for our specific model that we're going to try to take a database approach to. So as we get specific, we find that we need the customer, product, shop, vendors and sales. But as I said earlier, we're going to delete vendors because although it's necessary really, we just want to make it simple and keep to these 4. And by the way, what of the 4 types of entity are vendors? Well, obviously they're people, right? So even that salesperson who gave you a tough time in the shop, kept harassing you, wanting to buy something, really just trying there to help, really, they were people. Yes, they were. Right, well, what we're going to do next is look at the relationships. Okay, now what happens is a customer goes into a shop and buys a product, and that's classed as a sale. Okay, so now you might want to think about this, stop the recording and think about how these would relate to each other in specific terms, because we need to get really specific, and that's why you need to do what's called a systems analysis and also look at the data flow of a system. But in this case we're just looking very generally at a retail model. So have a pause and think about that. Well, I did tell you that mathematics comes into this. We need to talk about something called cardinality. Now, that's a posh word for how many relationships one entity has with another entity. And the cardinality shows how much of one side of the relationship belongs to how much of the other side of the relationship. In fact, we do talk, as you'll see, and show visibly terms of left and right hand side of entities. So we talk about on the left hand and the right hand. First, you need to state for each relationship how much of one side belongs to exactly one of the other side. For instance, how many customers belong to a sale, and how many sales belong to a customer? How many sales take place in a shop? We need to know what that is, because we're going to be modeling it. We're going to be needing to make it possible in our database for us to manipulate those relationships. So we need to know the scale or cardinality of them. Now, I don't like mystery tours in tutorials, so I'm going to show you where we're going. This is what we're going to end up with. Now, this particular kind of modeling is the kind I use in my teaching. There are different kinds. You might have seen what's called crow's feet. It doesn't really matter. The way of modeling that matters is that we actually do get the relationships pinned down and the cardinality correct. Now, what we're talking about, you'll see there's a 1 here on the customer side and a many on the sales side. So we're saying a customer makes many sales. It really isn't going to be very difficult to understand at the end of the day. But I want to show how we get here. So bear with me as we look at the little bit of mathematics we have to enter into to pin down the cardinality. Now, cardinality is actually also used in set logic. Might be interested to know. Right, let's look at the relationships. Customers have a relationship with sales. One customer can buy something several times. We tend to use the word many, as you'll see as we go along, instead of several. Sales has a relationship with customers. One sale is always made by one customer at a time. Customers have a relationship with products. One customer can buy multiple products. Products have a relationship with customers. You see how it's on both sides, left and right. One product can be purchased by multiple customers. Customers have a relationship with shops. One customer can purchase in multiple shops. Shops have a relationship with customers. One shop can receive multiple customers. And shops have a relationship with products. In one shop there are multiple products. Products have a relationship with shops. One product can be sold in multiple shops. Shops have a relationship with sales. In one shop multiple sales can be made. Sales have a relationship with shops. One sale can only be made in one shop at a time. Products have a relationship with sales. One product can be purchased in multiple sales, and sales have a relationship with products. One sale can exist out of multiple products. It's important we find out all the relationships. There are 4 entities, and each entity has a relationship with every other entity. So each entity must have 3 relationships, and also appear on the left end of the relationship 3 times. Above, we must make sure we don't miss any. So how do we know how many relationships there will be? Well, if we've got 4 different entities and each relates to the other, we know that we will have 4 times 3, which is 12, and here we have 12 if you count them. Now if we look closely at this, we can see that for example, customers and their relationship with sales. One customer can buy something several times. We can call this a 1 to n for number, n for number, 1 to n times. And for sales and their relationship with customers, one sale is always made by one customer at the time. It's a 1 to 1 relationship. So we've got a 1 to n and a 1 to 1 in the first 2 lines here. We also want to make sure that these arrows are for those with a cardinality, which is really 1 to n or 1 to m. We use m and n so that we don't get mixed up. You'll see later why that is. In other words, the 1 to 1 relationships, they're not really of great interest to us. If you think about it, it's not what we need to know. What we're interested in is when something happens that we need to take note of and store. We're interested in the 1 to n's and the 1 to m's. But we find also there are m's to n, that is, where multiple things happen and we have multiple relationships between entities. Now the next slide may make that more sensible. If we look at this slide, you can see that we've resolved to get rid of the 1-to-1s, we're not interested in those, and we've rationalized and written down the relationships between these entities in terms of, we might say, occurrences of relationship. So here we've got customers have a relationship with sales such that one customer can make many purchases. Customers have a relationship with products where many customers make many products. Buy many products. Customers have a relationship with shops where many customers may shop in many shops. And sales have a relationship with products where many sales take place of many products, and shops have a relationship with sales where one shop may have many sales, and shops have a relationship with products where shops sell many products. Now we've got the cardinality right, okay, and you might think, well, that's good, isn't it? However, it's not, because what we need to do in order to make a relational database, the modern kind, is actually apply some mathematical algorithms. We need to actually be able to make this happen in a digital machine, a computer. So what we need to make that happen is to have one-to-many or many-to-one relationships, depending on which way you're looking at it, left or right or left. Because it turns out that the m to n, we can't actually make them happen in a database. There's no way to program them. We just can't do it. So therefore we don't. What we do is we set up what eventually will be called tables when the database is made. We set up sets of sets, and we can always get back the original table that we wanted, as it were, the many-to-many relationships. We break those down into other entities, convenient entities. Anyway, let's see that in the next tutorial.